So, biggest departures from C++. These aren't in order, but that iota and that, oh, yes. Yeah, you can basically make an init function, and that'll be like that. So inside of a package, you can say func init, and that'll run before main. So it's just another function you declare. So there's two special functions. There's main and there's init. And those are the only two functions that you can't really name your functions. So yes. Cross packages? Yeah, and I'm not 100% sure on the order between different package modules and things like that. I don't really use it very often. But yes. It's all in the spec, though. The spec is really, really short. Has anyone ever read the C++ spec? Right? Can you? I haven't even been able to find like where to get access to it. I think you have to pay for it. Okay. But yeah, no, this is you can read this in about 15 or 20 minutes. It's really cool. Okay. So some of the biggest departures are that iota and const. I don't know if you remember, but how we declared variables and things like that earlier is very, very different than C++. It's a lot more fluid. It's really fast. But it's still perfectly 100% type safe, and that's important. I don't want to have to be bothered with types unless I do something wrong, and then I want to know exactly, that's when I want to be bothered by types. And Go does that for you. So it's like a balance between a Python, like a dynamic language, and C++ with stronger type system. So let's talk about that a little bit. Here I'm declaring an enum, basically, of tokens. And so all of these are tokens. I'm declaring some that are visible to other people and some that are only internal to my package token. And what's interesting is now I've declared a token to be type int, but I'm going to give it a function to turn it into a string. So it's different than an int, because now if you passed an int to printf, it would just print the number 5. But if you pass one of my tokens, it's going to print based on its type 4 or something else. So you see here, I even have a function, is this a keyword, that takes a token, and it checks to see if it's in between two certain ranges. I know that seems really, really simple, but when I was first writing a compiler, I saw that in their token class, and it blew my mind, because I never even considered doing something like that. Basically, leaving things inside of an enum to make checking what you have a lot easier. Let me go over. Okay. So now I'm going to use that same package from before. I'm going to use, so if statements and switch, remember, you can have an expression. So I'm going to initialize a variable, and then I'm going to use it. And this variable only lives inside of this if block. And then I'm just going to print it out. And even though it's an int, or it was an int originally, now it has a string function. So when I print it out as a string, it's going to print 4. And same thing here for multiply. It's going to print like a star or something. So I've added types. In C++, you can type def something, but you can't add functions to it or anything like that. So this is a very different type system. It's a lot more powerful. Here, I'm going to get into first-class functions. So in the same way that I can add, I can declare a type that's an int and add functions to it, I can do that to functions as well. I can do it to maps and arrays or slices. And that becomes really, really useful for some problems. Here's just an early prototype when I was testing the messaging system. And what I wanted to point out was that I have an anonymous function here that just takes arbitrary data. And inside of this, before I pass it to someone that's going to use it, I transform it into the type of data that function knows about. So I have a component that only knows about graphics components. It doesn't know about event data. It doesn't know about anything like that. So before it even gets the data, I've already transformed it into things it knows about. So things are very, very loosely decoupled. The only coupling is right here in this code. I don't have to include headers from the two different modules. Yep. And that's first-class functions. So here's more. I'm creating a closure and just showing that y is captured by reference. So what's going to happen is I have y. I declare a closure that's going to use y. And it just says if x is greater than y, increment x, return false. I'm going to pass in 5. So the first time it shouldn't be. The second time it should be. And you see the first time it wasn't. Y got incremented to 6. The second time it was, y stayed 6. Now, the same thing in C++. I love lambdas. Lambdas were like my favorite feature of C++ because I used to like how complicated they were. I liked that no one else on my team understood them. I felt smart, you know? A lambda, are you guys familiar with lambdas? Okay. So I'm not going to explain too much about it. They have a capture clause that says what they're taking from the environment. Then they have a function, and then they have a return type, which looks very similar to how like modern languages do this kind of thing. And it's a very big departure from how C++ normally does this thing. But what's scary about a lambda is there's so much that can go into the capture clause. You have to really understand what you're doing here. So here I'm only capturing one variable by reference. That's easy. But what if I put a comma and an equal sign? Then what would have happened? So to do the same thing, it's about the same amount of code, but you have to understand a lot more. You have to have a lot more knowledge to be as effective. So now we're going back, and what I'm going to do is I'm going to add a function now to a function type. So I'm declaring a messaging function as a type, and what it is a function that takes an int, and it takes basically a void pointer. And then what I'm going to do is whenever when I want to, I'm going to print off the function. It's going to say messaging func, and then I'm going to actually fire the function. Excuse me. So what's interesting there is you can do anything you can do with the type system, you can do with functions. And that's a huge departure from C++, because in C++ you only mess with pointers to a function. So things like currying, things like making a function that captures one of the arguments of a function and modifies it, it's called currying. You can't do in C++ as easily. You have to use like lambdas or boost or this function object. Has anyone heard of it? But these happen naturally in a language like Go and a lot of other modern languages. Here's an example where I have an array of strings. And I want to actually add new functions to this, like a filter function to this array of strings. So I call it a smart slice. I say when I get a smart slice, I basically just check to see if everything in there has a prefix, and I return a new array. So here I create a smart slice just like I would create a normal array of strings, but now I can call my filter function on it. And you see that this time it gave me phi. If I just said f, it would give me everything in the list. You could do the same kind of thing to say add a mutex or a lock around some data that you need to put a mutex on if you had to. So you could say add, lock your mutex, mess with your data, and then unlock it. The type system is really, really powerful, but it's also really, really simple. Are there any questions on that stuff? Okay. Lastly, I'll just show a little bit of how I use that in the game. Has anyone written factories and stuff for their games? A little bit? Okay. Well, abstract factory is basically where you pass in a string or something like that. You don't have a concrete type, but you have a name of something that you want. And it knows how to give you a concrete type back. So if I had a graphics component, I could pass in the string graphics component, and it would give me an actual object. And that's great for serializing from, say, a text file or something like that. So here I'm doing something really, really similar, where I have a type name that they pass in. I have a user-defined factory function so that my factory doesn't change. And then I have a couple special types that I want to always override anyone else's types. Like I don't want someone to override my basic game engine types. That'd be difficult. So here when I actually go to serialize in the data, you see that I'm using reflection to kind of get the object itself. And then I'm going to use a type switch on the next slide, where I switch on the type, and then I use the name to actually serialize in the actual object. And if you guys have done this in C, it gets kind of complicated. You have to use a lot of templates and preprocessor magic to do it, or you have to write a lot of code to do it. And because serialization is built in, and because reflection is built in, this becomes really, really easy. And also with the type system, where I can cast something as a type. If it's not that type, it will panic and tell me. And this is just the serializing for a basic type, where it's the same thing. I get a piece of data, I switch on the type, I'm going to store it off to use it later, And then if it's a string, I'm going to set it as a string. If it's an int or something like that, I'll do more processing. If it's a bool, I'm going to set data type to be a bool on that field. So it's ugly, but it's really, really simple because Go is just a powerful language. Okay, and then I didn't talk about the principles in slices and arrays. There's references to that stuff later, but it's really, really cool.